So we have mentioned that Java uses both compiling and interpreting both of them. So what happens is that we're compiling the Java code into bytecode, which is amazing. Like the compiler do that to us. But the just-in-time compiler compiles the bytecode that we have into native machine code at runtime, just before it's executed on the hardware. This allows Java applications to run faster because it converts the bytecode into optimized platform-specific code right before it executes. So how it works? So compilation of Java code, initially it's high-level Java, and then it's going to get converted into bytecode by Java C compiler, which we have just seen. I believe there is a terminal here. Yes, the Java C. And the Java virtual machine like reads and interprets the Java the bytecode that we have at runtime using an interpreter, and the just-in-time compilation, just in time, and it's gonna be identified as a program run. It's gonna be identify the hotspots. The hotspots area is something that's frequently executed, and we have just mentioned that hey, if something very executed so many times, it's gonna be used as a just-in-time compiler is smart that it compiles those hotspots into native machine code. Those machine code methods are stored in memory, so the JVM doesn't need to recompile them in subsequent execution. So basically, it saves time. So this is why it's important, since just-in-time compile, let's just call it JIT. JIT compiles to machine code at runtime. The code can be highly optimized for specific hardware, and it's gonna be adaptable because Java virtual machine can optimize code based on actual execution. So if something gets executed so many times, it's gonna be saved in memory in order to be faster. So this is kind of way of just-in-time compilation works.